Good morning to you here. I just wanted to do a bit of a video here with my windmill system. Yesterday I've lost control over my windmill, which means I'm having some sort of wiring or contact issue with it. I couldn't turn the brake on, and I was getting absolutely no amperage load out of it, which when you lose control like that, that generally means you got to bring it down. So it did pretty good. It was up there for I'm going to say almost a year now, not quite a year, probably 10 months for sure. So we had to bring her down. We just brought her down. You can hear it's windy out there. It's not something you want to do in the wind. However, the mill was freewheeling and the wind just hasn't been getting any better. So we waited for a south wind because the tower lays down to the north. And we just laid it down. I'm going to show you how we laid it down, and then we're going to see what actually happened. I have a suspicion that it was just a faulty plug. And what happens is they just can't handle the amperage over time. And it usually, what I've seen in the past is it'll burn the prongs off. Just a typical extension cord plug, just like that one right there. You just get those cheap replacement ends, and it'll actually burn the prongs right off them. I've seen it do it before. And this one here, I put some heavy duty ones on, and as like I say, I think it's got to be a good 10 months it's been up there. So it was time for her to come down anyway. But when you start freewheeling like that in high winds, we're experiencing 20 to 30 mile winds here, so it gets pretty nerve-wracking watching that tower start to shake and watching the windmill just wide open pin itself. So we figured it was best to lay her down because they're actually calling for more winds here. So I'll take you out and I'll show you what we so I had to tuck away out of the wind here. So what I have is just a winch on the wall here up to a support on the garage there that's supported with a 2x8 that runs the full length of the shop here. So that's lagged in pretty good. There's an old car battery there. Obviously it's not doing so good, so we had to throw the charger on her. So this just hinges in the snow, and that's her laying down there now. So that's a 33-foot tower. It just pivots off the one point on the halfway up the mill here, not even halfway up. And it just lags on. There's a clamp up there that we lag in, and then we have these two support arms. And it's been really good, very good actually. We haven't had any safety concerns at all with it. It's a pretty sturdy system. But anyway, we're gonna go up there and we'll see what we can find out which is wrong with that, with the actual electrical end of things. So I'm already assuming that it's this one connection I have up there, which I have zip tied together. So I'm grabbing my cutters here. You may not be able to hear me out there, but I do want to show you how I have the windmill mounted onto the tower, and I'd like to show you if that is actually the problem or not. I'd like to show people my screw ups so that they can live and learn from them. So hopefully you'll be able to hear me in the wind, but who knows. So I'll give you another shot of the tower laying down here. You kind of get a concept of how it works here. And here's what I'm talking about here. This is what I think will be the problem. It's just two electrical cords. One goes right into the PMA, and this is a 14 magnet with a 12 volt stator in it. It's been very productive for me, and it's just mounted on some bearings there. So anyway, I don't know if I can do this with the camera on, but we'll cut open these. Just see if I'm gonna maybe pause here and we'll show you the aftermath if there is. Alright, I took it apart. It's not near as bad as I thought, but you can see a little bit of heat that's showing up on this one terminal here. Started to melt the plastic just a little bit. This is holding together really well, actually. So what I'm gonna have to do is I'm gonna have to test this to make sure it's the problem. But as you can see, maybe this should be hardwired, but I always left it quick attach in case I had trouble. So okay, I thought I'd explain this in the shop here where you could probably hear me a little better. What I'm gonna do, I got a little bit of signs of heat damage, or amperage damage, I guess you could call it, on the one connection there, but I'm not 100% sure that's what's wrong, because when I tested the rectifier that runs that particular mill, which is right there, I had nothing on all of the terminals. So that leads me to believe there may be something wrong, but other than just that melted connection there, and it's not even melted that bad. I've seen them burn the cords right off. So what I'd like to do is I have this rectifier that's just mounted to a piece of wood, and it just has a plug-in on it, and I just hook up my ohm meter to the rectifier. I'll take this out and plug it right into the PMA, and I'll spin her over, and I'll diagnose and make sure the PMA is still working properly. If it isn't, then I'll have to pop the PMA off, and if it is, then I'll know that it's probably that plug all the way down to the into the garage here. So if you can't hear me or anything out there, that's probably, I figured I'd explain this here first, so we'll catch you then. Okay, I got the PMA off. It was testing that there's something wrong with the PMA. I had literally nothing on my gauge, no matter what. If I put it on milliamps, amps, or volts, I seem to get nothing. So I took it off, assuming, you know, that I must have some wiring trouble in there. Everything looks intact. There's no magnets that have fallen out that I know of anyway. And my wiring that I've done in the back here seems to be holding up. Looks really good, but I just tested it and away it went, and I thought, oh yeah, Murphy's Law. But then I kept going with just my ratchet on here. You can usually swing about 8-10 volts just by turning it by hand, but I soon noticed it faded, so there must be a connection problem. It very well could be in here. If not, maybe I have a loose magnet or something. It's not making any growly sounds or anything, or don't get me wrong, she makes lots of growly sounds, but that's how it is. It's not making any grinding sounds, I guess you could say. So I think at this point we should pop this thing apart and just give her an annual inspection anyway. But I'm gonna point a finger here, or potentially at some stator wires or something here, and we'll see what we can come up with. Fortunately, I do have another one of these. These are, the guts are actually from Missouri Wind and Solar. Other than the tough startup, they are excellent power producers. They do get growly in low wind, and you'll find yourself throwing the brake on, because my tower amplifies a lot of the sound that this makes, and it actually makes it worse. So you have a light breezy day, if the windmill does start up, it'll sit there and growl all day, and it won't really make much power. So you might as well just throw the brake on and enjoy your Sunday afternoon. But other than that, I'm going to give the product itself a decent review. I don't have a lot to compare it to, but when I bought it, I did a lot of research before I bought, and I'm more of a do-it-yourselfer. I didn't need to buy a completely assembled one or anything, so I bought a 12, I believe it's a 12 magnet rotor, and then I bought a 12 volt stator. So another thing I wanted to mention here, anytime you do any work with your PMA, it's always best, I've found, to, if you work in conditions like I do where there's tons of little metal fragments, I do a lot of welding and stuff, these things will suck little fragments from all over. So I just lay an old pizza box down or something just to keep those little fragments out of there, because they will damage your stator and your rotor. Over here is the prop off this particular mill. I believe it's 39 inches or something. It's the Missouri Wind and Solar Raptor series, and overall I'm gonna have to give the blades a good review. If you I've played around with a lot of blade combinations, and I'm happy with 6 in my wind zone here. The reason being, if you go with a 3 blade, the mill's virtually only going to start up when there's enough wind. But I find it's very aggressive, if you will. I don't know if it turns any faster with a 3 blade, but its startup seems a little bit late for our wind zone. So I've tried 9 blade, and that starts too soon, and you find it's almost always turning. Whether or not it's making power is questionable, and that gets back to that growly sound. So I found the 6 blade, which they say you're not supposed to have an even amount of blades on your mill. As true as that may be, on this scale of mill, I don't find that a real crucial detail. The 6 blades, I had 2 6-bladers up, and I'm not gonna say one way or the other. All I can say for sure is that the 6 blade's been up here now for about the 10 months. This is the first time she's been back on the ground, and it looks to be in excellent condition. And honestly, there are days, you know, windy days there, my ammeter cannot keep up to what we have going on here. I had 3 mils. Right now it's not so bad. When I had 3 mils, that 50 amp ammeter was virtually useless. It was that needle was always buried. So a lot of warm components over there. So right now we're just down to 1 mil. We had a mishap. I'm gonna maybe show you what happens when you don't consider every angle of putting up a windmill. I'm gonna maybe pass some of that on to you guys. But as far as I can tell, this one here looks good. I'm gonna check that hub for cracks while I have her down. Check each blade for cracks, check the security of the bolts, that sort of thing. Just give her a general. She's been doing really good, so I might as well give her a once over. And we're gonna crack this PMA apart here and see what we can find with that. But like I say, overall, with the Missouri Wind, price-wise, is, if you don't know what you're getting into, the reason I see a lot of controversial views, and if you do your homework on anything you buy before you buy it, you're going to know exactly what you have before you even lay your money down. So I think a lot of the reviews that may be on the negative side come from people who may or may not know what exactly they're getting into. And do-it-yourself wind, I don't know if it's for everybody, but if you just start laying your money down without doing any research, you're probably going to end up with something you're not expecting. So you can't, there's no miracles in wind, so you kind of have to do your research and know what to expect. And you, how do you say, you gotta try and get the biggest bang for your buck. And I think this whole combination, I had the alternator housing. I bought the rotor and the stator, and they were both very reasonably priced. Normally, if you were to buy this as a complete unit, I think you'd be looking around the $400 to $500. I believe I bought the rotor and the stator for in around the $200. So I'm a thumbs up. This thing has been working great for me for quite a long time. It's been very reliable, and I just can't point a bad finger when the product does exactly what they said it would do. It's like I say, if you know what to expect, you're gonna know what to buy, I guess. So throwing money at wind is easy to do, and if you don't do your math, then I guess you're gonna come up with the wrong answer in the end. So anyway, that's my 2 cents on this. So we're gonna get this apart, and we're gonna see how 10 months of shit and abuse have affected the Missouri Wind and Solar. Over now. Okay, you can see I've got her apart here. Just wanted to point out a few things. You can see it's full of water. I dropped it in the snow. First thing I wanted to mention is on the shaft I have these spacers, and had it been up there, let's say another year, I probably wouldn't have got these spacers off. They would have, I wouldn't say corroded, not even a lot of rust, but they seem to be embedded on there pretty good. And might I suggest some anti-seize compound or some sort of lubricant on them, just to maybe prevent that. The other thing is, taking these things apart can be a finger wrecker. Simply because of the strength of the magnets coming out of the stator. So what I do is I put the jam nut back on with a washer just to grab onto, and then I hold back the stator with my hand, and you really have to give her a good one. You really have to pull. You kind of want to do it in one. You don't want to give up halfway through. It's kind of a commitment. Once you start, you don't quit. You'll find once you get the hang of it, but just get them separated as far as you can, as quick as you can. And then I always set the rotor in a clean surface. These magnets are very powerful, and I probably shouldn't get my camera or my phone too close to them. But I checked all the magnets. They're all secure. They're epoxied in there. There's nothing, absolutely nothing indicating that they are giving any grief. So we're going to call that good. So I just wanted to show my wiring, the way I did the wiring here, if you can see it or not. There's 3 wires coming off the stator, and what I've done is I've crimped each one, and then I've shrink tubed each connection, and then I zip tied it to the back of the alternator housing right here to keep those wires away from the rotor, and then I zip tied it again some more there. So you really want your wiring. This is one place you don't want to cheap out on your wiring. So now is a good time to give that bearing an inspection and possibly a little shot of lube. Because these things are spinning quite fast. I think they're doing upwards of 500-600 RPM sometimes. So we're gonna everything's looking good, but I'm still gonna pull that stator out of there, and we'll check the wiring connections, and we'll use the ohm meter, and we'll test our connections, make sure everything's good to go here, because we still haven't actually found out why this thing stopped working. So I'm still gonna blame it on my wiring here. But I don't see any signs of stator failure here, so we'll go from there. All right. Well, as you can see, I pulled apart my wiring here, and I'm not really seeing anything wrong with it. Not what I was hoping to see, unless we've got some issues inside the plug, but I'm not really seeing any evidence of overheating on this end of the plug here. So I guess we're gonna have to dig a little deeper here and check out the back side of that stator and the wiring on that. I'm gonna just quickly throw my ohm meter on here and we'll check for continuity. That's about all I can check for in my state of education, and we'll see what that brings us there. But the worst part about having something fail is not being able to find out what's wrong with it. So we're gonna keep digging here. Alright. Well, it would appear that this is no one's fault but my own. You can see we've had some heat here. We've had some definite heat, and it actually burnt up my connections here. So that's good. I'm happy to find out that the stator is still isn't going to be the problem. Actually, I'm very happy to hear that. So what we'll do is we'll get her fixed up again here and back on the road. We'll look at that. It actually melted the wiring right off of there, and it actually stuck it into the stator. So I wish this light would stop doing that. So yeah, anyway, there's our problem. So we are going to rectify that problem. So out for now. Okay, I'm just studying here my work I did a year ago, and I'm trying to figure out how to do this any better. But here I have connectors that I've soldered on. Like, these blue connectors have actually been soldered on, and then they go into a little machine bolt and nut, and I've got shrink tube over that, and then I brought all three together with, and I kind of finished the cord off again with more shrink tube, a couple pieces of shrink tube, trying to watertight everything, you know. And I'm looking here, and this thing has gotten so hot that it actually melted, or appears to have melted, the connectors. And I'm wondering how I could possibly do that particular connection any better. With solder and shrink tube, I don't really know of a better way. Obviously we've got some heat generated here, or we wouldn't have these melted connectors. So I guess I don't know what to say. I just thought I'd put that on there, that this thing must be generating a lot of heat, which brings us back to one of Missouri Wind's concerns is they put these holes in the center of their hubs to promote airflow, which obviously may not be a bad idea, simply because you can see the heat that's being generated. I've shot my temperature gun at these at lower temperatures and never had excessive temperatures, but this thing up on a 33-foot tower has experienced some serious amounts of winds. We've had winds of upwards of 60-70 miles an hour, and that's probably where this extreme heat's coming from. So I guess maybe in hindsight, maybe that's operator error. I should have had the brake on maybe. So but anyway, I just thought I'd show, you know, how much heat is being generated here. I do wish these wires were a little bit longer. It would be a lot easier to work with if we could get the connections farther away. And I have big mitts, so it's kind of tricky sometimes to make soldering connections and stuff without heating the stator, of course. So when you're soldering, you don't really want to blast this with the torch. So anyway, that's where we're at for now. Alright, well, I've managed to resolder on our leads here that come out of our PMA. I took a little bit different approach this time. I just soldered the two wires directly together with electrical solder, and then I put some heat shrink over top of it, hoping, of course, that, you know, if I can get another year out of it, I guess. If I had to do that once a year, that's not the end of the world, I guess. I can't figure out for the life of me what the heck this is, if it's just melted on there or if it's actually a part of the PMA, so I'm just going to leave it. It's not hurting anything. But as I got thinking more and more, I'm starting to question if I did solder those original ones, because the blue, I used the blue crimp connectors, and the blue crimp connectors were still on there, and generally when I solder them I take those off, and it's not likely I would slide them back on. So I'm starting to think I didn't solder it to begin with. So with any luck, this here is going to keep us fixed up here for at least another year, I'm hoping. So we'll start reassembly here. All right, as I was putting my rotor in, I had a closer look here and discovered that we do have a magnet that was loose. Not a big deal, really. You can see the way they're hooked in there. It's a good design because the magnet can't let go, and I don't think it was going to go anywhere. But you can see they've got epoxy on it all. Nothing wrong with that. I think it's just a matter of re-epoxying it, and we'll be back up and running. I just wanted to show you that there. Even with a close inspection, there were still, you know, you look at something and then you take a double take on. It's like, oh, that doesn't quite look the same as the rest. So that's kind of, I just thought I'd throw that on there. It's not a big deal at all. So we've got our stator in, and we've got our wires zip tied there, so they're out of the way. Gave everything a little bit of shot of lubrication there. So I will get this here fixed up, and we will be on our way shortly. Okay, just got my magnet refastened on my rotor here. I just wanted to point out a few things here. You'll see it right there. First thing, I did not slide the magnet all the way out. I only slid it over enough to get the one side glued, as I did not want to lose the if the direction of the magnet were to matter or whatever, and I just thought it might be a little challenging to get it through. That being a negative magnet, the two beside it being positive, it could be a challenge to get it back into that position. The other thing I wanted to mention, I used JB Weld Marine Weld. It almost has the same composition of what they used. I don't know if this is even approved for magnets. It's more of an aluminum based JB Weld. However, it is safe, as you'll see here. Aluminum, fiberglass, metal, plastic, virtually everything. I have used this stuff on aluminum radiator that I have in my greenhouse. But as I just discovered, two things. First one, do not use a screwdriver to, you can use it to mix it, but don't use it to apply it. The other thing is some of the compounds in here are magnetic, so you'll find when you start bringing them close to the actual rotor, they will get drawn to the magnets. So food for thought, use something plastic to apply it with. And like I say, I'm not worried about that magnet flying out of there. I just want to keep it from moving side to side. And I'm assuming that this is alright on a magnet. It doesn't say you can't use it on a magnet. So I guess if there was anything catastrophic that happens, I will post it. But if not, we'll just assume that this stuff is just fine. So just wanted to point out those few little things if you find yourself in the position of re-gluing a magnet. I do know that things get hot. This stuff is supposed to be good for a pretty reasonable temperature, and it's waterproof, and it's supposed to have a strength of 3,960 pounds per square inch. So it takes quite a while to cure, but I'm not going to stand the mill back up here right away, so it'll be in the shop here and it can cure. It's a little too windy to stand the mill up, so when I get this repair done, it's just going to stay down until such a time as the wind comes down here, and we'll pick our moment here. So I've got some lubrication down in there. I use grease and or 3-in-1 oil. it seems to be working just great. The bearings seem fine. This bearing here is a sealed bearing. It's showing signs of play a little bit, just a smidge. However, if I'm not mistaken, it had signs of play before I put it up there, as this was a used alternator and I did not change the bearing in it. So I'll just give her a shot of 3-in-1 there, and with any luck she'll be good for another year or so. I know you can buy those bearings. The main thing being, we don't want to damage the shaft is the main thing. So I'm going to continue putting this thing back together. Hopefully this time she goes and I don't notice anything else wrong, because I actually had it put back together and then I noticed it. So it's a real chore to get that rotor out of there, so it'll work muscles you didn't know you had. So maybe even a two-man project for the most part. You don't want to pull on the stator when you're pulling the rotor out. You don't want the stator to come out, because it'll tear your wires off, and you start breaking those wires and you could be in for some trouble. So anyway, that's where we're at here. I'll start reassembly again, and we'll give her a test when we're done. Alrighty, PMA's reassembled. We've got our plug back on. She's all lubed up. We're still going to give that epoxy a chance to, or that JB Weld a chance to do its thing. Just thought I'd do a quick test on it here. So again, I've plugged in my rectifier that's hiding right back here, and I've just got my multimeter set here to 10 volts, and it's hooked up to the rectifier on the rectified side, on the DC side of the rectifier. And if I just give this here a bit of a crank, if I can do it one-handed, I don't know if you can see that, but we're making like 4 volts or something there just by spinning the ratchet. Actually, we're shooting upwards of here, which would be 6 to 8, somewhere in there. So we can conclude that problem is solved for another year here. Easy fix. You know, considering the abuse and the temperatures that these things would generate, and when I say abuse, I don't mean it's out of its element. What I mean is when we get the odd 60 to, well, yeah, I'm gonna say 60 mile an hour wind up here. It's not real common, but we'll get gusts that you can't even stand up in on certain storms and stuff. And honestly, I put a lot of faith in this particular one, simply because it has stood the test of time. And this is honestly my first breakdown on this, and I will point the finger at myself. It's nothing of the product I bought. The loose magnet, that is, you can get that anywhere. So I'm going to give the product a thumbs up again. It's in very good mend. I did have a little bit of rust on the back side of the shaft, so all I did was put a little bit of 3-in-1 oil on it. It does prevent rust, just a little bit of lubrication there. The stator looked amazing. It looked like just like the day I put it in, and the rotor, same thing. Honestly, I'm so happy with this. I am going to look into ways of reducing the cogging, or not reducing the cogging. The cogging actually, in my setup, the cogging works to my advantage, and the reason it does is my windmills are not turning when the wind is not strong enough, and I like that, because why put the wear and tear on something if you're not going to generate power in a 4 or 5 mile an hour wind? Well, maybe a 5, but you're not going to accomplish a lot. I like to target the winds that are going to charge my batteries quickly, and we spend a lot of time outside in the yard, so what's the point in having a windmill out there that's whizzing by you that's not doing anything? So it is nice. I do like the cogging. The only thing I don't like is the vibration it sends down the tower, and I am going to look into possibly rubber mounting, and I have considered it before. I may have even bought some rubber motor mounts, I'm not sure, but because this thing just sat up there and flew, I had no reason to bring it down. So thankfully my tower system comes down real easy. It was quite a pleasure to have that system that I just threw together with an old winch. It works quite well, and like I say, if there's any questions on that, I do have another video that elaborates a little bit on it, and then this particular video has that little bit at the start there. I might set up the tripod when we stand her back up. I usually like to stay behind the camera, but it is very, very user friendly to stand the tower up. It is not a big deal. Right now our biggest menace is the 2 feet of snow back there that we got to deal with, but other than that, you know, it's actually a system I'm very happy we have. It makes life a lot easier for us. So I'm going to put this off to the side for now, and I want to show you guys what happens when you don't dot every I and cross every T. And I'm gonna grab some parts here that have failed on me, not because of their not because of fault in the product. It's because of fault in my design. So I just want to put some of this stuff on here so guys maybe don't follow in certain footsteps. You know, you got to know what goes and what doesn't. So I'm gonna grab a few things here, and I'm gonna show you some of the failures I've had in the past.